everybody, and welcome to Topic 3, Lesson 4, the concepts of remainder theorem and factor theorem. So here we are looking at this concept. Before we go on, last example, I did talk about the remainder theorem and how P of A is equal to the remainder of P of X divided by X minus A. And so we can use this remainder theorem and this idea to find factors of a polynomial and to rationalize the factors that we find of a polynomial. So the remainder theorem states that if a polynomial P of X is divided by X minus A, the remainder is P of A. So when X minus A is a factor of P of X, we can show that P of A is equal to 0. So we have P of X equals Q of X times X minus A. So again, if A is a factor, then you're going to replace A in there, and you'll get the 0 here, right here, because A minus A will be 0 times your quotient, which would be 0. Conversely, when P of A is equal to 0, we can show that X minus A is a factor. So we have P of X equals Q of X times X minus A plus R, where P of X equals Q of X times X minus A. And remember, our remainder now is P of A, P of that divisor solution. So P of A is replaced in here. Now, using the remainder theorem, if we have a factor, then we should have no remainders, and therefore this is 0. So then we have P of X equals Q of X times X minus A, or factored form here. The factor theorem formalizes these 2 points. The factor theorem states that the expression X minus A is a factor of a polynomial P of X, if and only if P of A equals 0. So again, you cannot have a remainder for it to be a factor. If you have a remainder, it is not a factor or a 0 or a solution of our problem. All right, so let's use this for example 4. Let's jump into example 4 here. Use the population of tortoises, or use the population. So you use the remainder theorem to evaluate polynomials. The population of tortoises on an island is modeled by the function P of X equals negative X cubed plus 6X squared plus 12X plus 325, where X is the number of years since 2015. Use the remainder theorem to estimate the population in 2023. All right, so let me grab this. Move that over. That was all right. So we're going to look at the synthetic division here. So again, I'm going to jump over here. I'm going to make this -1, 6, 12, and 3, 25. All right, I'm looking at the difference between 2023 and 2015, and we're looking at 8 years difference. So if I were to make this a divisor, this would be X equals 8 or X minus 8 that we're dividing it by. So I'm going to put an 8 here, my nice straight line. Move down -1. -1 times 8 is -8. We get -2. -2 times 8 is -16. We get -4. -4 times 8 is -32. And that's 325 minus 32 goes to 93. So P of A, which is 8, will equal to 93. So the estimated population of 2023 is 293. Honestly, the other way we could do this, and this would be good if you didn't really have a calculator, but the other way you could do this is do P of 8 equals -8 cubed. Notice how I kept the negative on the outside there, because we're just replacing just the x, not the negative. 6, 8 squared is 12 times 8 plus 325, and we should get to 93 as well. All right, so that is using the remainder theorem to find the population of tortoises. And then a technology company uses the function r of x equals negative x cubed plus 12x squared plus 6x plus 80 to model the expected annual revenue in thousands of dollars for the new product, where x is the number of years after the product is released. Use the remainder theorem to estimate the revenue in year 5. So your value is going to be 5 in this case, and you're just going to find the remainder and then use that to find P of A. All right, guys, I hope you have a fantastic day, and I will see you in the next video.